Let's discuss a little bit more about components, access, and game objects. When you select a game object in the hierarchy, in the inspector, you're given a list of the different components. Not only can you add components, but you can adjust their values individually. You do not have to do this through the inspector. In fact, you can edit, manipulate, and add additional components and even new game objects through a script instead. Let's go ahead and create a new game object in our scene, and we're going to call it Sphere Generator. Let's right-click, create empty, press F2 to edit the name, and then type Sphere Generator. And hit enter. Make sure Sphere Generator is selected, and click on Add Component. Go to the bottom and select New Script. Let's call this Sphere Generator. Notice how the name of the game object being Sphere Generator does not conflict at all with the script also being called Sphere Generator. Within our project view, on the assets level, we'll notice that we now have a script called Sphere Generator. Double-click it to open it in your editor. The idea behind this script is that it's going to create for us new game objects at random locations that display 3D spheres wherever they're created. Not only will it generate new game objects, but we're also going to test the components, add our own components, and adjust their values as necessary. To start with, we need to create a new function. This function is going to be called createRandomSphere, and it will be responsible for creating one new sphere at a random location. Let's make this method public, gameObject, because it will return to us a game object, and then we will say createRandomSphere. Now we'll get a warning here, and that's because we're not returning a game object yet. It's reminding us that we need to make sure we return a game object before this method finishes. To create new game objects, we just use the new keyword as we do with other variables. First, we're going to declare the variable, which will be called temp, and then we're going to set it equal to a new instance of gameObject. Temp is equal to a new gameObject. However, since we want to create a game object that is actually a sphere, Unity provides us with a helper function to automate this for us. If we were to run this as it is, it would create an empty game object, just like if we were in Unity, we right-click and create an empty game object. So instead of using this, instead we're going to call gameObject.createPrimitive, enter, and then we're going to choose the primitive type that we want to create. Go ahead and hit enter to select primitive type, because that's what I have selected here, dot, and then we'll choose the kind of primitive we want. I would like a sphere. Now you might ask, well, how did you even know createPrimitive exists? Well, that's what the documentation is for. If you go and search in the documentation under the scripting API for gameObject, it'll tell you all the properties and methods that are available. A static method of the class gameObject is called createPrimitive. If we select that, it will give us how to use this method as well as any types it takes in as parameters. We can also then learn what primitive type even is by clicking on primitive type and then seeing all the different types here. This line of code is going to create for us a new game object that's going to have two components attached to it. A mesh filter, which is going to have the data that creates the sphere itself, and then a mesh renderer, which will draw the object on the screen. You need both of those in order to create a 3D object. Now let's finish off this method and then call it within Start and confirm that this works by going back into Unity and pressing play. So first we need to return temp. The reason we need to return it is because we made a promise that we would return a game object right here. Now we need to call this method in order for it to actually fire. And in Start is a perfect place to do that. So let's just call createRandomSphere, semicolon, and I'm going to hit Control S to save, or File, Save up here. Let's go back to Unity, make sure that this is attached to our game object, and then hit the Run button. Unity will take a second to update with the changes you made to the script. Then go ahead, check Sphere Generator, make sure your component is actually attached. That's a huge mistake people make at first. And then go ahead and hit Run or Play. And what you'll notice is that over here under Sphere Generator, and then what you'll notice is within our sample scene, we now have a new sphere within it. And this sphere is created within our hierarchy, just like all of the other game objects. Now this red is not terribly flattering, especially for when we're recording tutorials. So let's go ahead and edit Preferences. And I want to change my play mode to something not quite so obnoxious, maybe a nice light pink value instead. Now when I hit Run, we can clearly tell that we're in play mode, but it's not going to hurt our eyes nearly as much. Now notice that when I exit play mode, the object disappears. Why? because it only gets created within the start method of that script. And that start method only fires when we run or play our scene. It doesn't actually exist within the save state of our scene. This is great because it means we can procedurally create content inside of Unity. You do not have to set everything up inside of your hierarchy to begin with. As I mentioned, the game object was within our hierarchy panel here on the same level as all the other game objects in our scene. However, if we were to create hundreds of them, then we'd very quickly clutter our hierarchy view. And this is where a parent or child relationship can be important for organizing things, as well as transforming objects. Let's go back to our code. Now, to show an example of this, why don't we call createRandomSphere over and over and over again? Instead of having this execute within start, if we instead have this execute in update, depending upon our update rate, we're going to get, somewhere between 30 and maybe 90 spheres being created every second, or maybe even more. So let's go ahead and Control S to save and go back to Unity and hit play. Let's go ahead and hit play. And what we'll notice is a huge number of spheres are being created, and our hierarchy is very quickly being filled with them. Let's go ahead and stop the program. Now let's jump back into our code and make some changes to organize things a little bit better. If we use parent-child relationships, we can actually organize our scene a little bit better than what we just saw. Now, parent-child relationships can be used for organization, but their real purpose is for transforming objects in a parent-child relationship. That is, when the parent moves, rotates, or scales, all the child objects will do the same as well. Parenting is going to be controlled through the transform component. That's the component that every game object always has, even an empty one at the top. So after we create our temporary object here, what we're going to want to do is access the transform of that object and set it equal to a parent transform object. To do that, let's type temp dot and then transform, and now dot parent. Now there's actually two ways to set the parent of an object. We could do it either through dot parent, or there's also temp dot transform dot set parent. The reason there are two versions of this is based on how much control you want when moving one object from one parent to another. We're going to get more into this in future lectures about transformations, matrices, and vectors. All you need to know is that setParent gives you a few additional options to control how that object is going to be moved as it changes from one parent to another. In this example, we only need to be messing with the simpler version, .parent. And all we have to do is set equal to whatever the parent object is. We want the parent object in this case to be the game object that sphere generator this script is attached to. If we look back in Unity, this is the game object sphere generator, and this is the script that we're working on. So we want this game object to have child objects of whatever it creates underneath of it. So we are going to be using the sphere generator game object. What's important to understand is that this is a script. This is a component. This is not the game object. We have to access the game object from the script. This is easy. All we have to do is type this dot gameObject dot and then transform. And now we have accessed the transform of our game object, where this is the script. You did not have to write this. You could have written just gameObject. I personally like using this because I come from a C++ background, where using this as a pointer to this current instance is how you kind of move around and navigate. It also allows me to use autocomplete, so I can move up and down all the different properties that I have in my class instance, and then select the right one and hit enter so I don't have to type as much. We'll keep this method in update for now to prove a point. Now, if you notice up here, we still have that asterisk next to the .cs file. I'm going to hit Control S to save it. If you do not do that, the changes will not go to Unity, and you won't see anything that you've done when you hit run. Let's go ahead and hit the play button. And what we'll notice now is we don't have an ever-expanding hierarchy over here on the side. Instead, we have this little arrow, which indicates a drop-down. And within that, we have all of the different spheres here. This is a great way to organize your scene. Knowing that all of those objects are under the sphere generator means it's much easier to manipulate, find, delete, and so forth, all of those objects in one specific spot, rather than having them all throughout the scene without any sort of a container holding them together. If we were to select Sphere Generator and select the game object and go to our scene view, we can move all of these objects together. Now, an issue you might notice is that Sphere has the same name. Even though we're creating hundreds of them, they're all with the same label. GameObjects have a name property, and we can change this to be pretty much whatever we want. In addition, the name has nothing to do with a unique identifier. That is something that uniquely identifies that game object. Names can be the same for multiple objects. Let's go ahead and in code change the name so that we always have a unique name for every single game object. So after we create it, let's hit enter for a new line and hit temp dot name is going to be equal to, and let's change this to a string that's equal to sphere underscore and then whatever current number we've created. So let's do sphere underscore, and let's add to that a integer value. That means we need to create a rolling count of random spheres that have been created. We could do this per instance, which means for every sphere generator we create, you would have the same 0, 1, 2, 3, 4, 5, or we could do this class-wide using a static variable, so that regardless of how many sphere generator instances there are, all sphere generators are going to have unique names for each sphere that gets generated. Let's do the class-wide one just to see an example of static variables. Up here at the top, let's create a new variable. Let's call this private static integer value, and then let's just call this numSpheres. It's going to be equal to 0 to start with. What we're going to do is use this numSpheres value down here by calling sphere generator, because that's the name of the class. It's a class or static variable, hitting dot, and then type numSpheres. And since this is technically a string, while it will convert things automatically for us, it's always good to just type dot to string to make our intentions clear. Now, the last thing we need to do is every time this method gets called, we need to increment the count. Otherwise, this will continually just create sphere underscore 0. So down here before we return, let's do sphere generator dot numSpheres plus plus and hit save. Once again, go back to Unity and hit play. And now what we'll see is a continually updating and increasing list where the number increases every time we create a new sphere. Let's stop this and actually duplicate sphere generator several times and then hit run again. Now each one of these sphere generators will be creating its own. Let's pause this actually so it doesn't get too crazy. So on update, what's happening is each one of these sphere generators is creating one of its spheres. This one created the first one, sphere 0. We go to 4, this one created the next one, and because it's a class-wide variable, it once again, through the class itself, updated the count so that they all share the same count. Just keep this in mind in the future that sometimes you'll want to create instance variables, that is, variables that are different or unique for each instance, and other times you'll want to create variables that are shared class-wide. Let's go ahead and delete all the excess sphere generators we just created. And while it's kind of fun to create endless seas of spheres, in reality, that was really bogging down the performance of our application. And we weren't able to control the total number of spheres that gets created. So instead, let's create a new method called createSpheres, where we pass in an argument, which is the number of spheres we want to generate, and then it uses a for loop to create that many spheres before stopping. Let's go back to code. So our intention is, instead of calling this method an update, we are instead going to be calling this through a new method called createSpheres. Let's create a public void, because we will not be returning anything, and we'll call this createSpheres. Create a parameter, integer, numSpheres, and we'll set this equal to 1. The intent is that whenever you call createSpheres, you're probably always going to want to create at least one, so that's why we set a default value of 1 here. Let's create a for loop, and then we're going to be calling within that for loop createRandomSphere. So let's do for int I is equal to 0, I is less than numSpheres, I plus plus. Now you might say, George, doesn't this variable here, numSpheres, have a problem with this one here? No. The reason is because the scope. This numSpheres scope is within this function, this method here. And this one will associate here. It will cover up the other one. If we wanted access to this numSphere here, we would use spheres generator dot numSpheres to get that variable. Now let's go ahead and call createRandomSphere. I'll just copy this, Control-C and Control-V here, semicolon on the end, and hit Control-S to save. Now we need to call our method createSpheres from someplace. I'm going to call this within start. This means that when start fires on this object, it will then create n number of spheres based upon how many we decided to pass in. Right now, if we passed in no parameters, it would create 1. Let's create 10 instead and hit Control S to save, go back to Unity and hit play. So hitting play, we see that sphere generator now creates 0 through 9 or 10 total spheres. At the beginning, I said that we would be creating these in random locations, so let's make that happen next. Let's go back to our code. The transform is not only where we control what the parent object is, it's also where we can control the position, rotation, and scale of the object. We're going to use the Unity random class to specify a three-dimensional location for each new sphere we create on the surface of a sphere. Let's type temp.transform.position, and we're going to set this equal to a new vector 3. We'll talk more about vector 3 shortly. However, this stores 3 parameters, an x, a y, and a z location. Both positions and scales, as well as Euler rotations, are stored within vector 3s. Now we could come in here and specify a different position for each of these, like 1, 2, and 3, but that would not be random. Instead, what we can do is look at the Unity documentation for the random class and utilize different methods inside of it to help us out. Going back to the Unity documentation, type in random. Within random, we'll do a search and take a look at these different properties and find something that might help us out. Here's one called onUnitSphere, which returns a random point on the surface of a sphere with radius 1, read only, which means we can't modify the value that's returned to us. So let's click on onUnitSphere, and what we'll see is that it actually returns to us a vector 3 object. So we're not going to need to create our own vector 3 because it's going to give us one to work with. So coming over here, we're going to remove this part and type in random dot and then onUnitSphere. Now the issue is that onUnitSphere is only going to return on a sphere of size 1. And since all of our spheres are size 1, it's very quickly going to fill up that entire space. What we want to do is make this much larger. Because this is a vector object, vector mathematics are supported. So if we type in vector 3 under the documentation and we scroll down to the very bottom, what we'll notice is that there are various operators, mathematical operators we can use, such as multiplication, which multiplies a vector by a number. A vector is a quantity that has both a size and a direction. By multiplying it by a different scalar value, we're going to increase its size. So let's go ahead and create a new variable that I want to be able to manipulate within the inspector. We can do this in 2 ways. We could declare it as a public variable, or we could make it an attribute by using serialize field. We can do a float random radius is equal to 10 for now, but this will be editable within our inspector. Let's grab this variable, come down here, and on random.unitSphere, because this is a vector 3, and we know we can multiply that by a scalar value, we can multiply this by random radius to make sure that we get a larger range of values that are coming into temp.transform.position. Go ahead and save, and we're going to go ahead and run this application now. Go ahead and hit play, and let's go to our scene view, and what we'll notice is that within our scene, we have created 10 random spheres at different locations. Let's go ahead, stop this, and increase that count to something larger, like say 1,000. Now, I would like to have control of this through the inspector so that I don't have to continually edit this code. So let's create a public int and just call this n equal to 5. And we'll replace create spheres with n here. Now, n is not a terribly descriptive variable name. To help people out who might be using our code, instead, we can use the attribute tooltip, which allows us to specify a string we want to appear as you mouse over that variable within the inspector. And here we can just say number of spheres to generate. Let's go back to Unity and see the results. So here, if we select the sphere generator and we look here, we see the random radius, which is size 10, and then we have a value n. And if we hold our mouse over it, you'll notice it says number of spheres to generate. Let's increase that to a good number, like 1008. And then the radius, let's decrease this to something like 4 and hit run. And here you can see that we have generated 1,000 and so spheres, all within that size that we dictated. And it looks kind of interesting, almost like some sort of a molecule. Now this is nice, but it might be more interesting for us to learn how to edit the individual components of these objects, maybe make them a little bit more unique. Let's change the colors of the spheres as they're generated randomly. Now to do this, we're going to need access to one of the components on the object. When we used create primitive, as we saw, it automatically generated a mesh filter and a mesh renderer. To get access to those different components, we need to use the add component method. To get access to the mesh renderer and mesh filter that are created, we need to use getComponent. So let's do temp.getComponent, and this is a generic. Generics are similar to templates if you're familiar with C++ at a surface level. That is, we're going to specify the type of the object that we're working with here. In this case, the kind of component we want to try to get is going to be the mesh renderer. GetComponent will return to us the first instance of a mesh renderer it finds attached to that object, if there is one. If there is not a mesh renderer, it will return null. Let's store this value in a variable. So we'll do mesh renderer mr is going to be equal to temp.getComponent mesh renderer. Now we should probably test to see whether or not the mesh renderer exists. Otherwise, we'll get an error because we're trying to access functionality that we don't have access to. So let's do an if check. If mr does not equal null, then we can manipulate it. Now, one of the things we have access to through a mesh renderer is the material of the object. And for simple objects like this primitive sphere, the material is going to allow us to adjust its color. So let's do mesh renderer.material.color. And now we need to set this equal to a new random color. Now, once again, this is the perfect time for us to consult the documentation. If we do a search for random and color, what will pop up is this particular method, random.colorHSV. This will return to us a random color using hue, saturation, and value, as opposed to using RGB. It doesn't really matter because we're doing this randomly, so we don't know what it is to begin with, so what does the method matter as to how it's being generated? Let's go ahead and type random.colorHSV. Now what we'll see is that we have randomly shaded each of these with a different color. If we click on one of these spheres and go in the inspector to the material down here, you'll see that each material is going to have a different color assigned here to something called the albedo channel. For right now, just think of albedo as the true color of the object if no shadows or lighting was taken into consideration. Now, before we finish up, let's see how we can add a new component to an object. This is very simple. Just like how we used getComponent, we're going to be using addComponent. I want to add a light source to each one of these objects. So under here, let's go ahead and do temp.addComponent, and then we're going to specify a light. AddComponent will return to us the component that gets created. So let's go ahead and create a light, temp light is equal to addComponent light. Now that we have that component, we can manipulate all the values as we would in the inspector. And in some cases, we can manipulate a lot more than what the inspector has available to us. So let's do temp_light.color, and we're going to set that equal to the color we stored inside of the mesh renderer by doing mesh renderer mr.material.color. Now the light that is emitted from the object will match the color stored within that object. Let's go back to Unity and hit run. Click on Sphere Generator, and 1000 is a bit much, so let's reduce that maybe to 25. And I'm going to make this a little bit larger, maybe size 8, and then I will hit run. And let's go to Scene View, and what we'll notice is that each one of these objects, well, when they're sufficiently close to each other, the light on this object is casting onto this object here. You might not get perfect results, you might not see it. You'll notice that all the light in the scene is not impacting every object, and that has to do with the fact that we're rendering quite a lot of objects. 25 objects and 25 light sources is a lot to render, and there's different pipelines for how you handle lighting. Therefore, we'll get to that in future lectures. Just realize that you're not going to see perfect results yet until we make some changes to things and learn more about things like deferred rendering, which allows us to render 50, 60 lights at a time, as opposed to what we're doing now, where at most you're probably only seeing the results of maybe 4 or 5 of these light sources, depending upon your system and what the settings are. Now, with all that, you have learned how to create simple primitive objects, how to access the components via script, how to add your own components, and manipulate those values when you need to.